a load of items. They all have different uses and therefore different properties that make them useful. However, they are all made of the same material. Polyvinyl chloride, shortened to PVC. PVC is made of many monomers of chloroethene, also known as vinyl chloride, joined together to form a polymer. But all of these items have different flexibilities, and PVC is naturally very hard and brittle. So, how is this possible? The secret is an additive called plasticizers. Plasticizers have been in use since the 1930s and have become known as an everywhere chemical because, well, they are everywhere. They are in food packaging, cosmetics and personal care, healthcare, children's toys, flooring and more. They are small molecules added to a polymer to increase the flexibility and durability of polymers that would otherwise be too brittle. They may also be added to personal care products to make fragrances last longer. This diagram shows how plasticizers go between the polymer chains, and this allows the chains to move more freely and therefore to be more flexible. There are a few models used to explain how this occurs. Firstly is the lubrication theory, which suggests that plasticizers act as a lubricant, reducing friction between rigid layers, allowing them to move more freely. Secondly is the gel theory, which extends the lubrication theory and proposes that plasticizers break up the intermolecular interactions between polymer chains. Thirdly is the free volume theory. The free volume of a polymer is the empty internal space available for the movement of a polymer. This increases as a polymer reaches its glass transition state, the point where polymers transition from a glassy state to a rubbery state. Plasticizers increase the free volume per volume of material and hence lower the glass transition temperature, meaning the polymer becomes more flexible even at lower temperatures. Different types and different amounts of plasticizers result in materials made with the same polymer but with different flexibility and durability, hence the varied use of PVC. The most common plasticizers are phthalate esters, which make up 80% of the plasticizer market. Phthalate esters are diesters with a benzene ring, where the R group is a linear or branched alkyl chain. They are made by reacting phthalic anhydride with excess aliphatic alcohol. The addition of different alcohol results in many different phthalates. One example is bis-2-ethyl hexyl phthalate, or DEHP for short. It was the first phthalate to be introduced to PVC in 1931. DEHP is made from the reaction of phthalic anhydride and 2-ethyl hexanol. It is found in many household items as well as in medical devices such as IV tubing, catheters and blood bags. We're going to continue to come back to DEHP in this video. Despite their low cost and useful properties, over recent years, phthalates have become the centre of controversy and news headlines. Phthalates are not covalently bonded to the polymer they're part of. This means they can leach out of the material with small environmental changes, and humans can come into contact with them through inhalation, direct and indirect ingestion, dermal contact, as well as in medical settings. A 2016 study found that 96% of people had phthalates in their blood. They are easily absorbed and metabolised and can stay in the blood for up to 2 days. Infants and young children are more prone to exposure due to their hand-to-mouth behaviour. This graph shows 8 different phthalates and the exposure measured in women aged 15 to 44, infants, toddlers and children. As you can see, except for DEP, where women have the highest exposure, largely from cosmetic products, the most stark difference in exposure for women compared to infants and toddlers is with DEHP and DIMP, where the exposure is largely from indoor environments, but also from toys and TVs. So what is the problem? Some phthalates have been found to be endocrine disrupting chemicals interfering with the body's hormones. Being exposed to our example phthalate, DEHP, during critical periods of prenatal development has been linked with lower testosterone production and disrupting normal male reproductive development. It has also been associated with adverse impacts on neurodevelopment, such as lower IQ and problems with attention and hyperactivity. However, lots of the research into potential effects of phthalates has only been conducted on rats, and the extent to which this data can be extrapolated to humans is still being studied. Regulation of phthalates is complicated, as phthalates in different settings are regulated differently, and they are not required to be listed on ingredients lists. But this does not stop governments from taking action. Here are a few examples of this. In the EU, 8 phthalates, including DEHP, are on an authorisation list, meaning that products containing more than 0.1% of a specific phthalate are banned unless they apply for a specific permit. In the UK, medical devices must comply with the requirement of UK MDR 2002, which states that any risk, for example exposure from DEHP, must be outweighed by anticipated benefits to the patient. Then, in 2015, the Scientific Committee on Emerging and Newly Identified Health Risks recommended that the replacement of DEHP in medical devices should be considered. So, what is the future? One solution is to stop using PVC altogether. 95% of phthalate testers are used in PVC, so this would go a long way. For example, many cling films are now PVC free. Many industries are trying to move away from the use of PVC and other plastics anyway, due to other environmental concerns. Another solution is to find safer phthalates and plasticizer alternatives. Diisonyl cyclohexane 1,2-dicarboxylate, also known as DINCH, is an alternative to DEHP in PVC products, such as toys, medical devices and food packaging. DINCH is still easily absorbed by animals and humans, however, has not yet been found to have any developmental or reproductive toxicity. But DINCH and other alternatives are still fairly new, and therefore any possible effects on humans are not yet fully known. Phthalates and plasticizers are everywhere. They have helped to create many of the items that are part of our everyday lives. However, there is also concern over their safety, especially for unborn fetuses and young children. More research is needed to determine how harmful to human health they may be and potential alternatives to them.